Imagine a planet where temperatures soar high enough to melt metal, where the air crushes with the weight of 100 elephants, and acid rains scorch the ground. This is Venus, a world so hostile it makes Earth's harshest deserts feel like cozy gardens. Yet, hidden beneath its terrifying exterior lies a secret. Venus could one day become a second home for life. This is the story of how humans might transform this hellish planet into a lush, vibrant world teeming with forests, rivers, and maybe even cities. It will take centuries, creativity, and courage, but the dream is possible. Venus is Earth's twin in size and structure, but that's where the similarity ends. Today, its surface temperature averages 462 degrees, 863 degrees still hot enough to turn lead into liquid. The air is 96% carbon dioxide, thick and heavy, with a pressure 92 times stronger than Earth's at sea level. If you stood on Venus, you'd be crushed, roasted, and dissolved by sulfuric acid clouds in minutes. Even robots struggle to survive. The Soviet Union's Venera probes lasted only hours before failing. But Venus wasn't always this way. Billions of years ago, it might have had oceans and a climate like Earth's. Something went wrong. A runaway greenhouse effect trapped heat, evaporating water and turning the planet into a furnace. Now scientists wonder, could we reverse this disaster? Mars often steals the spotlight as a target for colonization, but Venus has advantages. It's closer to Earth than Mars, with gravity 90% as strong, better for human health than Mars's weak pull. Its thick atmosphere could shield against harmful solar radiation, and the carbon dioxide in its air could someday be used to create oxygen and soil. Plus, floating habitats in Venus's upper clouds, where temperatures and pressure are Earth-like, could serve as stepping stones. But transforming the entire planet? That's a bigger challenge. The first step is cooling Venus. Today, it's dense. CO2 atmosphere traps heat like a blanket. To remove this blanket, we'd need to block sunlight. One idea is to build a giant sunshade, a thin, reflective material orbiting between Venus and the Sun. This shield would cast a shadow, slowly lowering temperatures. Over decades, the planet would radiate heat into space, shrinking the atmosphere, as CO2 freezes into dry ice glaciers. But a sunshade isn't enough. Venus's air is full of sulfuric acid, which traps even more heat. To fix this, we'd send fleets of drones to release chemicals that neutralize the acid, breaking it into harmless gases. These machines would work for centuries, surviving the harsh conditions with rugged, self-repairing designs. As temperatures drop, the CO2 atmosphere thins. By year 100, the surface might cool to 100 degrees, 212 degrees. Still deadly, but progress. With the heat under control, the next task is creating breathable air. Plants and algae on Earth convert CO2 into oxygen, but Venus's air is too thick for them to survive yet. Instead, we'd mine water from icy asteroids and comets, crashing them into Venus to deliver hydrogen. This hydrogen would react with CO2, producing methane and water, a process called electrolysis. Over time, the methane could be broken down into carbon and hydrogen, further thinning the atmosphere. As water accumulates, Venus might develop shallow seas. These would absorb more CO2 and host the first microbial life, engineered organisms that thrive in extreme heat and acidity. These microbes would release oxygen, slowly making the air safer. By year 200, the surface temperature could drop to 50 degrees Celsius, 122 degrees Celsius. The air would still be mostly CO2, but with traces of oxygen and nitrogen. Humans in protective suits could walk outside, planting the first seeds of a biosphere. The final century is about nurturing life. Hardy plants, genetically modified to survive heat and drought, would spread across the continents. They'd break down rocks into soil and pump oxygen into the air. As plants grow, they'd stabilize the ground and create microclimates, cooling the planet further. Rain would fall, not acid, but clean water. Rivers and lakes would form, supporting insects, fish, and eventually small animals. Forests would emerge, absorbing the last remnants of CO2. By year 300, Venus's atmosphere might resemble Earth's, 21% oxygen, 78% nitrogen, with a comfortable temperature of 25 degree, 77 degree F. The once dead world would burst with life, flowers, trees, and maybe even animals. Humans could walk freely, breathing the air and farming the land. This vision is thrilling, but risks abound. Venus's rotation is slow. One day lasts 243 Earth days, so one side might bake while the other freezes. To fix this, we might nudge asteroids to spin the planet faster, creating a day-night cycle. Another danger is Venus's lack of a magnetic field. Without one, solar winds could strip the new atmosphere. A solution? Place a magnetic shield at a stable point in space near Venus to deflect solar particles. Ethical questions arise too. Should we meddle with a planet? What if terraforming disrupts unknown ecosystems in the clouds? These debates would shape the project, ensuring humanity proceeds with care. Terraforming Venus isn't just about survival, it's about ambition. It's a testament to human ingenuity, proving we can undo even the most catastrophic damage. The journey would unite generations, each contributing a piece to the puzzle. Imagine a child born on Venus, 300 years from now, playing under a blue sky, picking fruit from a tree. They'd look up and see Earth, a pale blue dot, and marvel at the ancestors who dared to turn hell into paradise. This future isn't guaranteed, but it's possible. Every step, from sunshades to engineered microbes, builds on science we already understand. The real question isn't if we can do it, it's whether we choose to try.